Chapter 4, Section 1, Classifying Triangles. I have a couple of warm-ups here. I have 3 warm-ups here. And for number 1, it's just a review, and it's not mandatory to write them down. Angle 2 and angle 6, those 2 angles are here, and they are corresponding angles, because remember that 3, 4, 5, and 6 are interior angles. They're between the 2 parallel lines. The transversal is here, and angle 2 and 6 are both on the right side of the transversal, and they're both above the 2 lines that were intersected by it. The measure of angle 4 is going to equal this angle right here, which is going to be 118 degrees, because they're corresponding angles. And then the measure of angle 3, well, angle 3 and angle 4 are beside each other. So remember, they're called linear pair, and they will be supplementary. So if angle 4 is 118, then angle 3 will be 180 minus 118, which is 62 degrees. Alrighty, we've been measuring and classifying angles. Like there's acute angles, there's obtuse angles. Remember, acute angles are angles that are smaller than 90 degrees. Obtuse angles are more than 90 degrees, and right angles are 90-degree angles. And you can name triangles with the same idea. I'm going to start with the obtuse triangle, because an obtuse triangle is a triangle that has one obtuse angle. Look, there's still acute angles in there. Think about obtuse means more than 90. So let's say this was a 100-degree angle. There's no way you could have 2 100-degree angles in a triangle, because that would add up to more than 180. And if you recall, all 3 of these angles have to add up to 180. That's something that most people know when they get to me. It's also something I get to teach you in geometry. So I'm officially telling you the sum of the 3 angles, the interior angles of a triangle, the sum is 180. Okay, so obtuse triangle has 1 obtuse angle. Acute triangle has 3 acute angles. This is pronounced equiangular. An equiangular triangle has 3 congruent acute angles. And yep, that's right. They're all 60 degrees. Because if they all add up to 180 and they're all equal, 180 divided by 3 is 60 degrees. If you have a right triangle, that means one of the angles is a 90-degree angle, and the other 2 angles are acute angles. Remember, the side opposite a 90-degree angle is called the hypotenuse, and those are the legs. And these are, I've only mentioned words. These describe a triangle by the measure of its angles. You can also describe a triangle by the measure of its sides. This is called classifying triangles. Classifying by angle measure, these are 4 possible answers. Classify by side length, these are 3 possible answers. If all 3 sides are the same length, it's called an equilateral triangle, lado, equal. So 3 congruent sides, and spoiler, every equilateral triangle is also an equiangular triangle. Isosceles triangle has 2 congruent sides at least, so that implies that an equilateral triangle could also be described as an isosceles triangle. These 2 sides that are equal, it doesn't matter where they are, but whatever angles are opposite them, those 2 angles are also going to be equal. That's something we'll learn later, isosceles triangle theorem. But right now we're just talking about classifying a triangle by its side length, so that would be an isosceles triangle. Scalene triangle, that's the word for, hey, these sides, none of them are the same. So here's an example. A review of the word midpoint. If y is the midpoint of segment Vx, that means y is right in the middle of segment Vx. Here's segment Vx. So if y is right in the middle of it, that means the length of Vy is 4.2, because that's what you get when you take 8.4 divided by 2. And the length of Yx is also 4.2. So they want to know if this triangle, they want to classify it by side measure. So I need to know the lengths. Oh, and which triangle they're talking about. They're talking about triangle VWY. VWY is this triangle right here, VWY, if you trace it out. So what are the lengths of the 3 sides? Well, VW is 4.5 units. WI, I don't know, it doesn't say. Yeah, it says it right here. Okay, WI is 3 units. And VY is half of 8.4, so it's 4.2 units. I didn't write the labels. You should write the labels. It's a scaling because all three sides have different lengths. Next, if point C is the midpoint of segment BD, so here we have this thing where something's in the middle again. So if this is in the midpoint of the whole segment, that means the length of BC is 1.7, because I asked my calculator to divide them by 2. 3.4 divided by 2, and this is 1.7. Or I did it in my head, it doesn't matter. Okay, so now the question says, if point C is the midpoint of BD, classify triangle ABC as equilateral. We're talking about ABC. ABC. This, oh, whoa, nice. That triangle right there, see these tick marks right here? Those tick marks mean that those two sides are the same lengths. So therefore, that is a scalene, I mean an isosceles triangle. Isosceles means it has two sides that are the same length. It can't be equilateral because BC is 1.7 and AB and AC are 1.2. Alrighty, so here it says find the measures of the sides of an isosceles triangle, and it has this word here. The base is KL, so segment KL is the base, and I didn't go over that when I told you what isosceles was. It has two sides that are the same length. The third side is referred to as the base, even if it's not like at the bottom. So if KL is the base, that means that KM and LM are the two sides that have the same length. So you can use that information to find the value of D. So since KM and ML are equal in length, which is given when they say the word base, because we know what that means now, I set 4D minus 13 equal to 12 minus D and just solve for D. They decided to add D to both sides. That would be this step right here. This is the algebra stuff. So that's where that 5D came from. And then they're going to add the 13 to the other side and divide by 5. So D equals 5. If D equals 5, how can I find the length of KM? Well, KM is given to me as 4D minus 13. And so 4D means I'm going to take 4 times 5, since D is given to me, since I just solved for D and it's 5. So 4 times 5 is 20. 20 minus 13 is 7. Okay, what's ML? ML is 12 minus D. So what I need to do is substitute D in here. 12 minus D is 12 minus 5, and that equals 7. That's kind of a neat way to check your answer also. Since I assumed at the beginning, I didn't assume, they told me at the beginning that this is an isosceles. So these two lengths are the same. So once I solved for D, I checked it, and yep, they both came out to be 7. And the third length is KL, and that's a D plus 6. And D is 5, so 5 plus 6 is going to equal 11. And so the answer to the question of find the measures of the sides of the isosceles triangle is right here. And notice how they didn't put a segment symbol on top. Putting that on top would be wrong. That says that's the name of a segment, okay? So you're not supposed to put that there. Erase that. The reason they didn't put it there is because they're talking about the length of the segment. So not putting anything there is a communication of length of KM. The distance from K to M equals the distance from M to L, which is 7. Okay. Find X and the measure of each side of equilateral triangle. They didn't even draw the picture this time, but if it's an equilateral triangle, that means that all the sides are the same length. And that means that AB is going to equal BC, and that's going to equal AC. They gave me too much information, basically. I can pick one of these and solve. So if I decide to just go with the first two, and I would say, well, since it's an equilateral triangle, all three sides are the same length, I'm going to start off by trying to find out the value of X by using this information. AB equals BC. AB is 6X minus 8. BC is 7 plus X. Solve for the variable. I subtract x from both sides. I'm going to end up adding this 8 to both sides. Every Algebra 1 teacher cringes if you do both steps in one, but I'm going to do it. I'm your geometry teacher now. 6x minus 1x is 5x. And 7 plus 8 is 15. So x equals 3. So it's not this answer and it's not this answer. It could be either one of these. And now to find out the length of the side, I'm going to take that 3 that I got excited and I didn't write it. And a fast one to get would be like, okay, I can see that if I put it in here, 3 plus 7, the answer is going to be 10. So I think it's this one. I could put it in one more. 13 minus 3 is 10. Yep, that's also an easy one. So I see that the answer is C. And that's it. This is a pretty simple lesson. It's the first lesson of the chapter that should get you going through the homework.